Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Okay, this is part 2. We're on to coastal landforms. Remember, part 1 then is where we talked about all the processes that we're just going to mention in passing very quickly here and not explain all those again. So please make sure to go back if you haven't gone over section 1 and are comfortable with all those processes. Alright, so we're going to start off with a headland and bay. Already we can see quite a high energy coastline here, rugged coastline with lots of cliffs, so we are going to go on and have a look at the headlands and bays. Headlands and bays then are formed because we've got a discordant coastline where we have areas of hard rock and soft rock, and we have the waves coming in here. And the waves are going to cause erosion, so all the different types of erosion, but in the beginning we can start with the idea of hydraulic action. So hydraulic action will attack the cliffs and it will erode back the soft rock quicker than the hard rock, and this will cause then this natural change in the area. So this is known as differential erosion. Softer rocks then are eroded more quickly. Headlands are formed, and then the headlands will cause a wave refraction. So the waves will move around the headland, and this will cause then the formation of a beach and a bay as the waves go through the shoaling process. As they're moving in, they lose energy on the refraction around the headland, and they carry sediment in and deposit it at the back of the bay. So as you can see there, it's just a step-by-step process, dividing it up into 3 different states, explaining the geology, then talking about the different processes, and then going on to mention the deposition and the bay formation in the last section. Always giving an example there, so there's 2 at the bottom for you. It's a good habit to get into, just have examples in each area. Now you'll probably have studied one particular coastline or done some field work there, so it's great to bring in real examples that you have, and you can always compare it to some of these as well if they are different. So here we can see it pretty clearly. We've got a headland here, and we have our bay on this side here. Same again, bay, headland, or bay, and a headland out here. So this is worked out kind of just as we thought about in the diagram, meaning that we've got soft rock and we've got areas and stretches of hard rock here. So those areas then are bands of hard rock and soft rock all the way along. Differential erosion has occurred here, just like we talked about in the diagram. And we can sort of see that there's a little indent here in this coastline place here, and there's a little bit of a gap there. So this would show us that the waves are in fact refracting around, and they're probably attacking these areas a little bit more. So the rates of erosion then increase in these areas. That is going to reduce the erosional rates and cause more energy to be lost in the waves, meaning that it won't be so destructive when it hits the coastline in the bay and will cause deposition, and usually we find a beach in that bay area. So that's quite a typical headland and bay sequence there. Now coves, halves and Dalmatians, so what we could see is in this case we've got the circular cove that's forming here with a narrow archway or entrance, and yeah, this is discordant coastline. So we've got the hard rock, soft rock, and hard rock features there, and we can see the soft rock then in the middle. So the waves are coming in at this angle here, and it just goes through basically initial processes, so through hydraulic action and abrasion. Weathering could have opened up certain areas of weakness, and it would be breaking through here. Sometimes there could be a river that's flowing out, and that might be the area of weakness that's attacked. But in this case here, we'll imagine that it's just a normal coastline with no river coming out. So the weathering and erosion then attacks this area here, eventually makes through into the softer rock, and once it's there, it can start to erode much faster with lower amounts of energy. So this rapid erosion then of the soft rock opens that up and then widens the cove. The waves then don't have the power to erode the chalk on the back, and this creates an area where we might find deposition and again a beach along this area here. So examples of that like Lulworth Cove. Now what's interesting about that then is the idea that we could have these same bands of rock, but it just depends where you're looking at. If you're looking at it from this side, then we would say discordant, concordant, and we can see then the reaction is going to be different. So here we see our cove, but here we have the potential then for a headland and bay situation. So it should look something like that in the end: headland, bay, headland, and over here we have a cove. So it's along the same stretch of coastline, it just has the different geological pattern where it meets the coastline. Okay, so that's our headlands, bays, and coves, and later on we'll have a little talk about Dalmatian coastlines and yeah, have a look at the difference there. Wave cut platforms or coastal platforms, yeah, changed because there's you might see it as wave cut platforms if you were to like search it on Google, but coastal platforms in most areas now and in most textbooks and everything, because it's not just waves that create it, but they do quite a lot of the work. So you have a high tide and a low tide line, and in this area we get a wave cut notch that is formed through erosion. So this means that hydraulic action and abrasion solution is working away to reduce the area of support at the bottom by creating a wave cut notch. This generally tends to happen more in the high tide area, more energy, higher amounts of erosion during that time. So undercutting it means that it's going to increase the stress on a singular point. And then you've got subaerial processes. So we can think about our maybe root action going into the rock. We could think about carbonation, especially if it's like a limestone, for example, and those chemical types of weathering happening there. So that's reducing the interior structure and the shear strength. This will cause then the shift in the equilibrium of the cliff and will cause it to collapse inwards. So it retreats back, and as it's retreating back, the process is going to continue, but less erosion is happening along the base and as the cliff retreats. So in the low tide mark, there's a restriction on the amount of erosion. This then means that there's going to be a flat rocky surface that has not eroded as quickly, while the cliffs still retreat back. This surface then is submerged during low tide and is often then exposed during low tide and covered during high tide. And this is a wave cut platform or coastal platform. Now remember, for each of these you've got to be able to identify photographs. You should be able to explain them all in your own words, and you should be able to introduce lots of vocabulary. Also, just to be able to identify it, they all look very different, so it's good to see different versions of them and to be able to explain them. Now, just going back one stage there to our headlands and bays, we have areas here where we're going to see more erosion, as we mentioned, wave refracting in around the obstacle that's blocking it. So due to that, then we would see that erosional features happen there and breaks up the headland eventually. So this could have